In breaking down the idea of aquaponics and what aquaponics is, we're going to first look at the aquaculture side of the equation. Globally, aquaculture is considered the fastest growing sector of protein farming. The biggest reason for the boom in fish farming is that fish are incredibly efficient at converting protein feed inputs to usable, harvestable meat. For example, a cow requires up to 6.8 pounds of protein feed to produce a single pound of harvested meat. Pigs, on the other hand, only require about 2.9 pounds of protein feed to produce 1 pound of harvested meat, making them significantly more efficient than cows. This is to say, if we have a limited amount of protein feed, we'd be better off growing pigs than cows, as we would get significantly more usable, harvestable meat from the pigs for that same feed input than we would from cows. Chickens only require about 1.7 pounds of protein feed inputs to produce a single pound of harvestable meat, making them very efficient, particularly compared to things like cows or pigs. It's for this reason that we've seen a boom in poultry farms across the world, particularly in developing nations where there's limited feed inputs and large population growth. Fish farming has become a very important tool in feeding global populations, as fish only require about 1.1 pounds to 1.2 pounds of protein inputs in order to produce a pound of harvestable meat. In looking at aquaculture and fish farming around the world, there's a number of techniques that are commonly used in order to grow large amounts of fish in controlled small spaces. One very common method of fish farming that's deployed all over the world is cage culture. This is a photo from one of my trips to the Volta region in Ghana. These are essentially large cages in which the fish are kept that are hung into the water from floating docks, typically in lakes or large rivers. It's important to note that while the cages protect the fish from the outside environment and from predation by other animals, the waste produced by cage culture farms simply flows into the lake or river in which the cages are housed. This means that all of the waste that's produced by the fish farming operations enters the local environments. This method of waste management pretty much depends on the dilution is the solution to pollution problem, in that we can artificially increase the carrying capacity of the lake or river or stream, and the waste that's produced by the fish will simply dilute itself out into the local waterway. While this is beneficial for the fish farmer and keeps the ammonia levels directly around the fish from building up and becoming toxic, it doesn't actually address the high levels of ammonia that are being released into the local waterways. Cage culture, when done wrong, or when done too aggressively in a small space, can lead to a spike in ammonia levels across the local waterway, and can actually harm the populations of native fish, macroinvertebrates, and even plants in the local waterway. Another very common method of fish farming that's being used across the developing world is pond culture. Here we see a photo of a fish pond being used to rear tilapia. This fish pond was implemented as part of an economic stimulus plan by the Ministry of Fisheries Development in Kenya. The goal of the economic stimulus plan was to provide local farmers with fish ponds in which to grow tilapia in order to diversify their offerings. One of the major problems with pond culture is that it's similar to growing fish in a goldfish bowl. As the fish produce waste in the pond, the ammonia levels in the water rise. As ammonia levels approach a level that might be toxic, about half of the water is drained from the pond and the pond is refilled. This is how the ammonia waste is removed from the fish population. But it's important to note these aren't goldfish bowls, and the waste isn't just being poured down a sink. Many of these ponds are up to 40 feet wide, 100 feet long, and 12 feet deep. This is an extremely large volume of water that contains a high level of ammonia. When dumping half of this water to get rid of the ammonia, we're not eliminating the problem of the ammonia, we're simply pulling it out of the fish pond and dumping it elsewhere. One of the problems that has been seen with the mass rollout of aquaculture fish ponds is the high quantities of ammonia-rich water that are being dumped into local environments. Water is pulled from the fish pond and dumped into a local forest, farmland, or even into a stream in order to get rid of it. Again, the ammonia hasn't been dealt with, it's simply been taken out of the fish pond and put somewhere else. As these systems are not recirculating and require that water to be dumped from the fish pond periodically in order to address ammonia, it's not uncommon for these ponds to be drained and refilled 3 or 4 times in the growth cycle of a single batch of tilapia. This makes pond culture of fish an incredibly water-intensive method of fish farming. In an effort to better handle the ammonia waste being produced by fish farming, tank culture and recirculating tank culture, or recirculating aquaculture systems, RAS, is being employed a lot in the fish farming industry. In RAS, recirculating aquaculture systems, fish are grown inside of tanks. Water is pulled from the tanks, filtered, conditioned, and returned back into the fish tanks. It's important to note that while recirculating aquaculture systems are less water intensive, and tank culture typically requires less water per pound of fish produced, mechanical filters such as drum filters or bead filters are used to concentrate the sludge waste produced by these fish cultures, and that waste is still often discharged into municipal sewer or a local septic system. Again, we see the harmful ammonia and high nitrogen waste produced by the fish not necessarily being dealt with, but being relocated. This is one of the big pressures that US-based and Canadian-based aquaculture facilities is facing today. The need to be able to appropriately handle, treat, and clean up the high nitrogen waste being produced. Tank culture doesn't necessarily have to be large, round, blue fish tanks like we often see in commercial salmon farms or tilapia farms. Here we see a commercial aquaculture facility that's using regular rubber totes as fish breeding tanks. I included this picture because I want us to start thinking about different materials that can be used as aquaculture and hydroponic growing equipment. I don't want us to necessarily get locked into thinking of growing equipment as something that has to be purchased from a hydroponic vendor, or aquaculture equipment having to be a perfect round blue fish tank with a gorgeous plexiglass window, particularly looking in DIY and more economic options for building and operating aquaponic systems. In a similar manner, if you're looking at building a commercial fish farm or a commercial aquaponic system, I don't want you to get locked into thinking that because you're commercial or because you're trying to build a commercial facility, that you have to use high-end equipment for every part of your system. Throughout this course and these presentations, we're going to look at where you should spend money and where you can cut back on capital expenses in order to build more economic systems. At first glance, it looks like the fish farm in this photo would be a small aquaculture DIY type operation because of the use of the big bubble bead filters, the wooden stands, and the rubber totes. This is actually a commercial fishery that breeds and sells angelfish and plecostomus to large fish retailers.